All right, so this is the lesson for 4.06 linear functions, January 24th, 2018. So let's go ahead and look at our calendar. So today is Wednesday, January 24th. I am not here, which is why I'm emailing you guys this lesson. This will also be posted in the announcements, and I'm also going to put it in the Class Connect recordings folder. So you'll be able to find it. Tomorrow we'll come back and have our regular normal scheduled time at 12:30, and then on Friday we'll meet at 1:30 again. So today is the only day where we're not meeting because I'm taking the day off. So let's go ahead and look at our learning targets for this lesson. I can sketch the graph of a function given a description of the situation it represents, and I can graph a linear function given its equation. So those are the learning targets we're talking about today. So sketching graphs, sometimes it is important to graph a function accurately. When this is necessary, we can use graph paper, a graphing calculator, or an online graphing tool like Desmos. Okay. Other times, drawing a sketch may be sufficient. A sketch is a freehand drawing that gives the reader an idea of the shape and location of the graph. There are usually no grid lines. It is common to label key points in a sketch to identify known or important information. You should also label the axes to help the reader understand the sketch. So here's an example. Here's a graph that I can generally figure out what it means. This axis is days and this axis is pages remaining. So I'm guessing at 0 days they had 400 pages remaining, and then throughout the day or throughout the time they finished their book in 16 days, so there's 0 pages remaining. So that's the kind of things we can figure out from a graph or just a sketch of a graph. So let's do an example together. Jack has a $96 gift card to spend on shrimp and steak. Yum. He wants to use the entire $96. The shrimp cost $4 a pound. The steak cost twice as much as the shrimp, so twice as much as 4 is $8 a pound. Okay. Sketch a graph that represents the situation and label the intercepts. So let's go ahead and look at the solution to this graph, what this looks like. So you're going to label variables. So X is your pounds of shrimp and Y is your pounds of steak. So just make one. You could have X is your pounds of steak or Y is your pounds of shrimp. It doesn't really matter as long as you define your variables and have one for each axis. You're going to write an equation. So they came up with 4x plus 8y is 96, and the reason they did that is because pounds of shrimp cost $4, so $4 per pound of shrimp is 4x. $8 per pound of steak is 8y. He wants to spend all of his money on some combination of steak and shrimp. So that's how they got that equation, 4x plus 8y. Step 3, find the x and y intercepts to create a graph. So if I plug in 0 for 8, I can just solve for the x-intercept by solving 4x equals 96, and you get 24. Same thing over here. I can solve for the y by doing 8y equals 96, and you get 12. So here is your general graph. Notice how there are no grid lines, but we do see where the y-axis, or where it intercepts the y-axis and where it intersects the x-axis. Let's do another example. So a hawk is at an elevation of 150 feet and spots a mouse. So he's at 150 feet and spots a mouse. It dives towards the mouse at a rate 25 feet per second. Sketch a graph that represents the situation. Label the intercepts and a point that represents the bird's elevation after 3 seconds. So label the variables. So this is talking about feet and seconds. So this is a time versus height graph. So let's make y our height in feet, and x is time in seconds. X is always time. Okay. So this is time in seconds, and then this is height in feet. Write an equation. So we're going to use just our regular y equals mx plus b. Okay. If he's diving towards the mouse, he starts up here at 150 feet, right? That's his starting point at 0. He's diving towards the ground at a rate of 25 feet per second. So he's losing height, right? So he's losing 25 feet per second. So negative 25x. So he's going to go down, right? He's losing height. So after 1 second, he's going to be 125 feet. And then 2 seconds, he's going to be 100 feet. So we need to figure out how high off the ground, or when does he hit the ground? Okay, so we're going to figure out when does he hit the ground. What is the value when y equals 0? So let's go ahead and find what happens when y equals 0. We already have the y-axis, or the y-intercept. It's 150 because that's where he started. So let's go ahead and solve. So if I move 25x to the other side and divide by 25, I'm going to get x equals 6. So here's the graph. That's pretty good. Use the equation to find the elevation after 3 seconds and plot it on the graph. So all we're going to do is take this equation and plug in 3 to figure out where is he. So negative 25 times 3 is negative 75, plus 150 is 75 feet. So after 3 seconds, he's 75 feet in the air. So let's go ahead and look at a little bit easier way here. Okay, so label variables. X is time. It's always time is x, and then y is height or elevation. Write an equation. So you can write it like this. You can write it as 150 minus 25x or negative 25x plus 150. It doesn't really matter. Find the x and y-intercepts to create a graph. Well, the y-intercept is 150. Right there is where he starts. And then the x-intercept is 6. We figured that out from before. To find where he is after 3 seconds, you're going to plug in 3, solve, and you get 75, and you get this point right here. Okay? All right, so let's go ahead and do this right here. A painting crew bought 30 gallons of paint for a job. The crew members used 3 gallons of paint per hour until they used all the paint. So 30 gallons of paint they started out with. They're using 3 gallons of paint per hour until they used all the paint. That's a T. Which sketch represents the situation? Well, what they start with, that is your y-intercept, okay? So whatever they start with, that's your y-intercept. So this says your y-intercept is 3, so that one's not right. We didn't start with 3 gallons, we started with 30 gallons. Same thing with this one. We didn't start with 10, we started with 30. So we can eliminate A and C right away because those two don't make sense. Okay? So if they used 3 gallons of paint per hour until they used all the paint, well, 30 divided by 3 is 10. So it's going to take them 10 hours to use all the paint. So the only one that makes sense is B, because they start with 30 and they end with 0 after 10 hours. So B is the correct answer because each hour they're losing 3 gallons of paint. So there's 10 hours remaining. Or not 10 hours. It takes them 10 hours to use all the paint. All right, let's do one more example. A submarine is 80 meters below sea level when it begins to ascend at a steady rate of 2.5 meters per minute. Sketch a graph that represents the situation. Label the intercepts and the point that indicates the submarine elevation 10 minutes after it begins its ascent. So let's look at what this looks like. So 80 meters below sea level is 0, okay? So 80 meters below would be negative 80. That's why you see this negative 80 right there. It's below sea level. If he's ascending, that's going up at a rate of 2.5 meters per minute, that's a positive slope, right? That's a positive 2.5 slope. So this is our equation right here, okay? So that's what you need to know sorry, I had to move stuff around. So that's the equation you need. So where he starts is negative 80, that's your y-intercept. Okay, that's always where you begin is always your y-intercept. To determine the x-intercept, you're going to have to set y equal to 0 and then solve. You get 32, so that's where he ends right here. It takes him 32 minutes to get to the top, or to get to sea level. Okay. To determine the submarine's elevation after 10 minutes, you're just going to plug in 10 for x. Okay, and then solve. So that's how you get 10 and negative 55. All right, so let me go ahead and do our next steps here. Go through all parts of the 4.06 lessons if you haven't already. Take the quiz today when you feel ready. If you need help, come to the help session tomorrow at 10 a.m. If you need extra help, watch this recording again. Okay, I only have 15 minutes to do these recordings. That's why they go by so fast. So watch the recording again if you need extra help. Otherwise, I will see you tomorrow and have a great day.